There are many sites where a temperature can be measured to give us some sort of surrogate idea of the baby's central temperature, and everybody will have their own favorites. But we're left with a problem. Measurement of a single temperature is going to tell us just how well the baby can maintain that temperature, but will tell us nothing about how much energy the baby may be using in order to keep that temperature constant. What this means is that even though the baby's temperature is normal, the baby may actually be exposed to quite a degree of cold stress and using up large amounts of energy in order to maintain its temperature. There are many responses to cold stress in the body. Everybody knows that one of the first things that happens is that your hands and your feet get cold as the body reduces circulation to the peripheries in an attempt to retain heat. This happens in the baby as well, and is a very early response. And in fact, we can use this early change in the temperature in the peripheries as a means of gaining more information about what is happening to the baby. In this slide, we show a graph of a baby's central temperature, in this case actually measured from the skin and the abdomen over the liver, and also on the bottom line, the temperature taken from the sole of the baby's foot. You can see here that during an episode of handling to recite an intravenous line, there's a significant drop in the peripheral temperature without any change in the central temperature. This baby at this stage is being exposed to some cold stress, but is actually able to maintain its central temperature. If you were measuring the central temperature alone, you would have no idea that during this procedure, the baby is actually being exposed to cold stress and having to utilize energy. This procedure was relatively short, and the baby recovered quickly without there being any significant change in the central temperature at all. If the cold stress continues, then there will come a point where the baby's central temperature falls. But by this time, the baby will have been exposed to really quite prolonged cold stress, and at this stage be using quite a large amount of energy in an attempt to try and maintain its temperature. So the persistence of a wide central peripheral temperature difference is an early indication that this baby is exposed to ongoing cold stress. In the babies under 28 weeks gestation particularly, a central peripheral temperature difference, with the peripheral temperature being measured on the foot, is usually around about 1 to 2 degrees centigrade. Any difference above 2 degrees centigrade is most commonly due to cold stress. Very small differences, less than a degree, are often due to overheating. And you can see here where a baby has been handled and then rewarmed, and actually it has been overdone, so that the central temperature goes high, and there's a very, very narrow central peripheral temperature difference. So continuous measurement and display of a central and a peripheral temperature gives us a very early indication of cold stress, long before there are any significant changes in the baby's central temperature. It therefore does give us a tool that allows us early changes in the environment, whether that's stopping handling the baby or increasing the environmental temperature, which allows us to minimize the effects of cold stress. Now, in my own opinion, I think this is best achieved using incubators in air mode control of environmental temperature. Servo modes, whether they be in an incubator or under a radiant heater, respond late because they are usually measuring a more central temperature. So they will only respond once the baby's central temperature starts to fall, and the baby will have been exposed to cold stress for really quite some time. Servo modes also result in a rather unstable thermal environment, which is something that has been associated with increased risk of adverse outcome in the preterm baby. You can also see an increased central peripheral temperature difference in babies who are peripherally vasoconstricted as a response to problems such as hypovolemia. And that's seen in this trace here, where you see this increasing central peripheral temperature difference over time. What is happening is that the baby is increasing peripheral vascular resistance in an attempt to maintain its blood pressure. In these situations, you can differentiate this from cold stress because in most cases there are other physiological changes, and in particular in this case you can see the steadily rising heart rate, which is the response of the heart to reduced venous return due to hypovolemia. Also, at this point the baby received volume infusion, and you can see this reduction in the central peripheral temperature difference followed by a fall in the heart rate. In this bottom slide, we see a pattern which is very typical of an infected baby, where you've got a high central and very unstable temperature and a very wide central peripheral temperature gap. This pattern is sometimes very useful in the early detection of possible sepsis. So what I hope I've shown is that even today, the obsessional approach to basic care, particularly maybe temperature control of the preterm babies, is essential if we're going to continue to see improvements, albeit small improvements, in the outcome for these babies. In reality, in day-to-day care, we only have measurements of the baby's temperature to tell us what effect the thermal environment is having. Measurement of a single temperature actually tells us very little, but the continuous monitoring and display of a central and a peripheral temperature gives us early indication of cold stress, allowing early intervention to change the environment in order to reduce the stresses on the preterm baby. So why do we start thermomonitoring? That's a very good question that goes back into the sort of history. Interestingly, we got into thermomonitoring as a consequence of actually some developments in computer monitoring systems. We were interested in using computers to capture trends from monitors and to display those trends in the hope that actually that would help in the care as people see trends developing. And one of the most striking trends was actually the temperature differences. We would record the temperatures on the same axes, so you would see a central and peripheral temperature, and you could see this sort of widening of the central peripheral temperature gap. And interestingly, the nursing staff really bought into this big time, because when we were experimenting with the computer monitoring, the actual computer were outside the nursery, but the nurses used to nip out to have a look because they realized that this widening of a central peripheral temperature gap wasn't a good thing. Interestingly, initially they felt that that was because the baby's feet were cold, and so they warmed the baby's feet up. But we began to understand that actually the baby was doing this because it was generally cold and was exposed to cold stress. And that really, I think it was that striking visual image of what was happening to the baby that really got us interested then in what sort of things were actually stressing the baby. What were we doing that was actually altering the thermal environment such that the baby was stressed? I suppose we got into it actually through the technology, interestingly. We'd been measuring two temperatures for a long time. Temperatures were displayed on a monitor just as numbers. And it was really getting into the sort of computer trend monitoring that we saw this sort of visual impact, this visual display of the temperatures widening and narrowing. And the nurses really bought into this. They could see that things really weren't right as the temperature gap increased. And now we use, sort of computer trend monitoring for temperatures and for all other physiological monitors, physiological parameters all the time. And with the sort of advances in technology, you can now see these trends really on the warming device itself. Initially, we used to put the temperature probes on the abdomen. Important if you do that to obviously shield them from any outside heat source. How do we go about it? Well, thermal monitoring requires the placing of two probes, one peripherally and one more centrally. In practice, in the newborn baby, the preterm baby, the only place to put the peripheral probe is on the sole of the foot. Now you can see low numbers on the monitor here. We haven't actually put these probes on the baby yet. The central probe can be placed in a number of places. Very commonly people use the skin on the abdomen over the liver. It's very important that when you put those probes in that position that you shield them from external heat sources using sort of reflecting pads, very much like this. There are plenty of other places that you can place these probes. What we've discovered over the years is that we can actually get some good readings by allowing the baby to lie on the probe with this probe actually between the scapulae. This means that we don't have to put any tape on the baby's skin. And that area of skin, because it's insulated, the baby's lying on a non-conducting mattress, actually heats up to reflect really quite accurately a more central temperature on the baby. So what are the benefits of thermal monitoring? Why are we still doing it after all these years? Well, I think it gives us a much better picture of the sort of thermal status of the baby. Increasingly now, I believe that we really have to be very obsessional about basic care. I think we've made a lot of major changes to therapies which made dramatic improvements in the survival of babies. But what we're seeing now are really much smaller changes. And I think if we don't get the basics of care right, then I don't think we're going to see further improvements in outcome in babies. And I think that temperature control is one of the most important basics of care. And what thermal monitoring does is give us a much better picture of what is happening to the baby. If you just measure a single temperature, you've got no idea about whether the baby is actually using any energy. Whereas with thermal monitoring, you can see very early the effects of cold stress. You can see this cooling of the peripheries as the baby begins to react to the cold stress. So I think this has become increasingly important to us. I think we noticed this a long time ago. We were struck by the sort of visual image of the thermal monitoring. And I think that over the years, nurses have continued to use it and wouldn't be without it. They feel very uncomfortable unless they're measuring both temperatures in the baby and give them a much better overall feel of what is happening to the baby.